right, we're going to take a look at some of the Canadian mathematics competition questions. These are chosen at random here. Let's take a look at this first one here. So for this first question, we have that you're given a point. In this case, the point is -2 and 7. You're told that this is the maximum point of the quadratic. You can see here your quadratic opens downwards. So they're essentially telling you the vertex of my quadratic. I've got the vertex of this quadratic given to me. And what they want you to do is from that and that only, they want you to find the value of k. So tackling this problem here, I think the first thing you'd want to do is at least put this in vertex form so I can kind of connect these values here. Again, your vertex here, this is like your h and your k. So I'm going to actually complete the square on this first. Let's go ahead and do that. So first step here is I'm going to factor that -2 out of the first two expressions, giving me x squared plus 2ax. All right, your b value in this case is 2a. Take your b value, divide it by 2 and square it. End up getting a squared here. So I'm going to go ahead and add and subtract that into my expression. Don't forget to close those brackets and put that k plus k back down. Now right away this expression here will factor as we've completed the square. So this becomes -2, and that'll factor into x plus a quantity squared minus a squared. Now as we move along here, I can now distribute the -2 into the expression. I want to put this in vertex form so I can see what I have here. I got 2a squared plus k. So now we've got some information we can use here. I now know that the vertex of this quadratic is -a 2a squared plus k. But the question told me that the vertex itself was -2 and 7. So from here, I can now equate the x coordinates. If they do line up, it must be the case that you can solve for a, and I can use that to solve for k. So from equation 1, I have a equaling 2, which implies here that 2a squared plus k is equaling 7, or in which case 2 times 2 squared plus k is 7. Let's go over here. End up getting here k is 7 minus 8, in which case I get my k value comes out to be a -1. So this question here from CMC, we've got a k value equaling -1. All right, let's take a look at another. So for the next problem here, they want us to solve the following equation. You've got a lot of expressions here, but a lot of these, if you take a look at these, some of these can factor, and perhaps this one can factor as well. And lastly, this one can factor too. That's probably a good place to start, is to factor this up to see whether we can get some common factors throughout and kind of take that out of the whole thing. So this will factor into x plus 2 times x plus 1, and this factors into x plus 4 times x plus 3. And I'm hoping I get some of those factors here. If I go to factor this, I end up getting x. This will factor into x plus 6 times x minus 1 equaling 0. So trying to answer this the easy way here, I did not get any common factors throughout. So I just kind of want to show you that I think that would be your first step. Now, if you mess around with this a bit more, is there possibly combinations that work out to our favor to have something that's similar here? If you take a look here, if I multiply these two out, I end up getting x squared plus 5x plus 6. And I'm going to re-expand these two together, giving me x squared plus 5x plus 4. And I'm just going to rewrite this one not factored. And now this helps out a bit more. You're getting a bit of a pattern here. You can see I have x squared plus 5x, x squared plus 5x, and x squared plus 5x. So I'm going to go ahead and do a quick substitution here. I'm going to let t be x squared plus 5x. And let's see if this is easier to see what we got here. I've got t plus 6 times t plus 4 plus t minus 6. So let's go ahead and expand this out a bit. Doing so, I get t squared plus 10t plus 24 plus t minus 6. Collecting like terms, I get t squared plus 11t. And you can see here we're getting a quadratic, which is what we want. to do, and I can quickly factor this nicely now. I've got myself a quadratic. This will factor into t plus 9 times t plus 2 equals 0, which gives us two values. It gives us -2 and -9. Now, I don't want t, I want x, but I know, if you look up here, I know that t is equal to x squared plus 5x. So I can go ahead and now say, okay, x squared plus 5x must equal -2, and likewise, x squared plus 5x must equal -9. So bring this to one side of the equation. I've now got this, and likewise, I have this. Go right to our quadratic equation here. I end up getting here x is -5 plus or minus. Go ahead and calculate your discriminant. I get b squared minus 4ac all over 2 times a. I get -5 plus or minus. This will be 25 minus 8. We get 17 over 2. So I've actually found two of the roots here. And likewise here, I'm going to go ahead and go right to the quadratic. This will be -5 plus or minus. This time we're going to get 25 minus 4 times 1 times 9 over 2a. And right away, you're going to see here that we end up with no real roots. And the reason for that is you can see underneath the square root sign here, we're going to get 25 minus 36. That'll be negative, so there's no real roots here. So in terms of the solutions for this, we have two answers. -5 plus or minus the root of 17 over 2 gives us our solutions for this problem here. All right, let's take a look at another example. So in the final example here, they give you this expression 2 over x minus x over 2, quantity squared equals 0. They want you to find the value of x to the power 6. So with this one here, I'm looking to find x to the power 6. I want to find, if I can find something like x to the power of 3 or x to the power of 2, I could use my exponent rules to find x to the power of 6. So right away, if you take a look at this one here, if I know that 2 over x minus x over 2 squared is 0, it must be the case that 2 over x minus x over 2 must equal 0. In which case, if I clean this up, you get 4 over x squared divided by 2x must equal 0. And in this expression here, implicitly, you know that x cannot be 0. So the only way this can be 0 is if 4 minus x squared is 0, which implies that x squared is 4. And right away, if x squared equals 4, I know x squared to the power of 3 is going to be equal to 4 cubed, in which case x to the power of 6 is 64, and that one is done. All right, this takes care of today's lesson here. I just wanted to go through some CMC questions here, Canadian Math Competition questions, and here's 3 of them. Thank you.